Hello, everyone. My name is Yuan Lai, and I am an assistant professor at School of Architecture, Department of Urban Planning at Tsinghua University, China. It's such a pleasure to be here in this workshop, and we would love to share some of our preliminary research that is related to sustainability and as well as urban computing. And this is the title of the paper is called Computing Places and Human Activity in Data Absent Informal Urban Settlements. This is a project that is done by me and also my student, Yifeng Liu. So at the beginning of the introduction, we would like to talk about why we want to focus on the informal urban settlement area. On your left, it's a screenshot of a figure that is actually one of the proceedings I published on PerCom 2 years ago, which is using open data sources to quantify different intersections in Manhattan, New York. As we know that increasing urban data resources provide a lot of information so we can quantify different urban phenomena and analyze different dynamic behavior in cities. So in this way, we can support complex planning and design decisions. However, study also proved that, as we know, there has been a profound disparity in digitization and data availability. So such disparity still exists across different geography, even within one city. So such differences really has been caused by a different level of socioeconomic development as well as a spatial formality. And previous research findings show that informal physical space, population, and informal activity usually have a low data coverage. That is due to the high fluctuation of human mobility, as well as the digital divide caused by the socioeconomic background. So as a result, that informal urban settlement area are absent somehow from the city open data inventory. So this will raise issues on data representativeness as well as missing information when we conduct urban computing. At the same time, informal settlement area are very crucial for sustainable development, attracting planning and design interventions as well to improve the quality and the condition of buildings, streets, and public space. So despite such importance, informal urban space and informal area very often will suffer from a lack of data and information due to informality. So this is where we're trying to understand that what are the possible computation solutions that is in a data poor environment. So based on such backgrounds, and this leads to some main questions we're trying to investigate in this project. So the first question is, to what extent can we compute places and human activity in such data absent informal urban settlement? Then what would be a feasible digitization process with very limited data resources? And finally, how can computation assist complex decision-making for future sustainable planning, design, and management? So based on these questions, we formulate a overall research workflow. So the research workflow, this flow chart or this diagram has been showing an overview of our research process. So through after the introduction, usually we conduct some literature review, mainly cover 3 aspects, including conventional methods for spatial analysis, computational cognition in urban space, and the existence of a data poor phenomena in cities. And in terms of the data and methods, mainly we conducted some experiments involving data integration, site survey, and to develop different computing strategy. And we will also talk about the finding and discussion as well as conclusion later and in the later slides here. So in the research area of urban planning, generally speaking, previous scholar from geography, computer science, cognition science, and urban design has investigated the theory and the methods for constructing an analytical understanding of a place. So analyzing the spatial configuration and characteristics of a site are the core interest of a city planning. Because the perception of a site is very contextual and situational, and usually based on personal experience, conventional methods that are usually qualitative, are not data-driven. This is why the conventional perception of a place or the site survey are very largely based on manual observation, human conducted survey, and interviews. So some well-established and widely adopted theories, including the image of the city by Kevin Lynch, and the people observation approach articulated by Yang Gale, as well as the site survey layering technique by Ian Mark Karg. And the layering technique later somehow provide inspiration for the GIS technology eventually. But overall, all these urban design or urban planning methods usually follow an observation, abstraction, and analysis process. And with rapidly growing urban data and computational capacity, so the different area of the research discipline has been investigating computational cognition and of the urban space through different approaches and aspects. This could be from the network, morphological configuration, or the imagery aspects. So first of all, the graph structure of the streets represent the primary structure of the urban spatial configuration, and this has been well investigated using spatial syntax. Using such methods, planners can quantify and classify different levels of the neighborhood accessibility and the connectivity of the street network. And from a morphological aspect, urban form and the density analysis can reveal different spatial patterns in cities, and not just involving physical attributes, but it's also possible to integrate social, environmental, and the demographical features. And this can review that how, based on different location, the places can create different perceptions involving walkability and accessibility for pedestrians and bicycle users as well. And from the imagery aspects, since we, a human, sense places and perceive spatial characteristics based on visual factors, so this area has been largely investigated through computer vision technology and imagery data analytics. So for example, studies have been proving the feasibility of evaluating the urban appearance of the streetscapes using Google Street View images, and that this somehow provide another way to, as a objective approach to quantitatively understand the quality of a space and the design quality of the public realm in the city. And through the studies and investigation involving computational methods, studies also reveal that the data are not ubiquitous as we think in reality. So the data, usually do not cover the entire extent of the cities, and this has been proven by a couple, many research projects, done by different research groups and in different locations, specifically focusing on the informal urban settlement that is often do not have data. In particular, the outskirts and the semi-urbanized area with many informal buildings and roads and activities are often ignored since they are not digitally documented as data. For example, as you can see, they are different research methods to address such issues by leveraging the ubiquitous nature of the cell phone technology, the mobile phone data, to understand the public transit, the informal transit system, or to use urban data to trying to quantitatively measure the inequality of the neighborhoods across the different locations in the city. Therefore, identifying a viable digitization approach for the informal area or the informal places is very critical for urban planning, particularly for sustainable development, emphasizing on the ecological, economic, and the social justice. And this workflow, the flow charts, and provide more detail in terms of our data and the methods involving different steps such as data integration, the manual site survey, and the computing strategy to combine the digital model with different data sets, as well as some key findings. And the data collection in this project coming from two sources. One is the digital model that is created by the designers. We have a team of architects and the planners who are working on the 2D drawings and the 3D spatial models from the architectural perspective. At the same time, we do have some urban data sources coming from open sources or the web scraping and the other technique that is used for data mining. So the challenge here is how can we combine these two type of data or two type of information together in this research. As you can see here, some of the data are collected from the manual site survey. So the students actually go on the site and they will document their observation, no matter involving people or involving the physical objects in the environment. On the other hand, such information will be transferred into the digitized version, through a computing procedure. And this is not just involving the programming process, but also utilize a lot of design softwares as well. So this is how we're trying to combine the urban design site analysis with urban data computing through an integration process. And for the specific site, since as we mentioned that this study, we want to focus on the data poor environments and due to the informality of the urban space. So we selected Sijie Street, which is a low-income neighborhood on the outskirts of Beijing as a very specific testing bed or a study site for this project. And the Sijie neighborhood is very special because it is a residential neighborhood located in Beijing, but it's also next to the fifth ring road and covering an area about 1 hectares, which was formerly it was a commercially oriented residential neighborhood that is designed or developed through many years. It has been some discovery of the historical features on this site as well. And according to the Beijing City Master Plan, this place, it is planned as an ecological wetland with a small amount of a built-up area, so for the preservation purpose. So therefore, in the future, the balance between ecological sustainability and the local residents, their demands, is a central issue for the site's future development. And despite the unique ecological, physical, and economic features, this place currently has very little digital representation. As you can see here and on your right, this is a screenshot from OpenStreetMap. And the OpenStreetMaps there has been showing very little digital representation of the built information, the built environment within this area, even though we can see from the images that there are a lot of buildings and they are informal road networks on the site. And so in recent years, this district or this neighborhood has been developing in very low speed, and it is a low-income neighborhood with very cheap housing, poor living condition, and a floating population who usually work in the service industry. So they had very low-paid job as well. And so the site surveying, this slide shows you the site survey process. So this process includes walking through all physically accessible road network to gain a human experience, specifically on the spatial configuration and the streetscape quality. According to the local activity, our students collect pictures to document location-based characteristics such as informal built structures, informal parking, informal activities that they observed, and informal public space. This figure has illustrated a spatial scope of the survey and some examples showed here as images involving different informality on the site. And we also conducted a survey on the building configuration involving both the location of the buildings and the height by counting the building floors. And the digitization process converts the spatial information model into programmable, the data that can be calculated and being computed in the programming environment. So this process mostly involves vectorization, image geo-tagging, and the spatial statistics. We establish a data processing and analytical pipeline, integrating multiple process, by using the Rhinosources 3D, which is an architectural design model, QGIS, which is a GIS software, and the Python coding environment. So a general digitization proceeds in the following orders. We first create the geometrical information by drawing the building footprint and outline the building outlines as polygons. And then we extrude building volume as 3D dimensional massing, as you can see here on your left. And the street networks are being modeled as polylines. So with such a digital model, we then geo-reference the geometry based on the location. and then convert the architectural geometry into geographical information system data. And then we can construct a grid, which is 4.5 meters, the 4.5 meters by 4.5 meters resolution to cover the full extent of the study area. So this is where you can see that we some sort of combine the 3D dimensional massing from the 3D model software with the geographical information data. In terms of analysis, we define multiple spatial and environmental characteristics and to generate the spatial statistics based on this grid. In this preliminary study, we developed 4 essential metrics, which include building density based on the total building surface, building land cover ratio, which is the land area divided by the built areas, and the tree canopy coverage, indicating where are the greeneries currently, and the proximity to the street network, showing the connectivity and availability to transit. These measures are all computed using the same grid as what we showed in last slide. So in this way, we can ensure the quantitative output share the same spatial resolution and the georeference. And then we use this output to define multiple thresholds and to identify the feasible cells for the informal activity. So one example here to show you is how we can calculate and conduct spatial statistics of the building density based on the total building surface. And so in this way, we do, this gave us a very direct understanding of the density of the built environment and where are most people currently living, considering this place is mostly a residential area. And this is the calculation of the building land cover ratio. And this is gave us a deeper understanding of in terms of the density, in terms of where has been built and where are the potential open space that is not have a construction on the site. So after showing the data digitization process and the computing methods, we would like to show you some preliminary findings. So the first finding, actually not the direct computational output, but through the process of this study, that is, we find out that there has been a very unique value of a human survey that is very difficult to replicate through spatial computing in computer. So this is, for example, this is a diagram showing you as a spatial analysis using traditional urban design approach. So what you can see here is that such human survey actually provides you a very abstract but very systematic understanding of the site, and that we have been very struggle and to recreate such logic in the Python environment using data computation. And you know, the sum of the statistics of what we calculate has been the quantitative analysis do reviewing some interesting correlation and the relationship between the informal activity or informal utilization of the space with the characteristics of the space. So for example, when we look at the place-related measures, it shows that for example, the figure A here shows informal places are usually close to a street within 10 meters. And this finding resonates with classic urban design theory from Jim Jacobs regarding the street life as a mainly a major part of the public life in urban space, especially at the neighborhood scale. And the figure B here shows there's no clear pattern between informal spaces and the tree canopy coverage. So the majority of the places that we find out which are suitable for informal activity actually do not have any tree coverage. And this reflecting the scarce of the vegetation on the site, as you can see from the previous slide. But at the same time, we do consider that this result can be not just showing you where are the current trees located, but we can also find out where are the informal area that potentially can need more trees to be planted and as part of the future urban planning strategy. And another finding or discussion we would like to share is we have the whole entire process of this study reviews obstacles when digitizing an informal settlement urban area. So some major preparation work involves such as on-site manual survey, the field trips, digital modeling, GIS mapping, as well as spatial data conversion integration that is conducted in the Python environment. So we consider this is a core it's a core challenge that is essential for conducting computational research in a data poor environment, because we need to utilize different tools and the information that is coming from different sources in different formats. On the other hand, that as I mentioned, we do find out the urban design approach is with human spatial cognition and the sensor plays provide a very unique value. So this is where we think is very necessary to further explore how can we combine these two methods together. So therefore, we established some sort of a hybrid approach in this project to integrate computational cognition and urban design methods for site analysis. Hopefully, as we continue exploring this topic, we will be able to find out better solution to combine the human spatial cognition with computational analytics. So in conclusion, that in this research project, we mainly explore digitizing an informal urban area with zero data representation. And based on the site survey in Beijing, and we tested a hybrid approach using both urban design methods and the data computing. The comparison between humanistic and computational approach reviews and unique aspects of to combine unique aspects of human cognition on the site. And so we further explore a possible hybrid approach to combine the human design thinking with data computing. So hopefully this hybrid approach may provide new tools and evidence for objectively measuring urban conditions in a data poor area to support planning decisions and design strategy for sustainable development. And there are definitely a lot of limitations that and the future work needed, especially we need to collect more data reflecting the informality, no matter informal area, the informal physical space, as well as the informal activity or the observation from the local people. And this will be some future work we will be continue doing. So that will be the share. I think the overall this project, what we have been has been doing, and we hope to hear from you, and we welcome any questions and comments. And once again, it's very nice to be here, and we look forward to hearing from other research teams project as well in this workshop. Thank you.